All right, so what do we do when we have ions? Okay, so far we've been talking about electron configurations for neutral ground state elements. Well, what happens with ions? Well, cations are positively charged, okay, and we are removing electrons. Anions are negatively charged, and so we're adding electrons. When I have my transition metals, okay, and I ionize those, metals like to become cations, so my transition metals are always going to become cations, so they'll always be positively charged. For those, we're going to remove the highest s electrons before we touch the d electrons. Okay, so for transition metals, we always remove the s electrons first. Okay, so we always do that when we ionize. So let's take a look here. All right, let's try, let's say calcium. Let's look at calcium. So calcium, we've got argon, and then we have a 4s2, okay? Now calcium has 2 valence electrons. It likes to lose those 2 valence electrons. So calcium likes to form a +2. So calcium is going to lose those 2 4s electrons because to make a positive ion, I have to take away electrons. So now calcium's configuration is going to look like argon, which is neon 3s2 3p6. Okay, so that is calcium ions configuration. Let's look at fluorine. Okay, fluorine is in period 2. It has a configuration of helium 2s2 2p5. Okay, so fluorine is a nonmetal. It likes to form anions. So fluorine forms this -1, okay, which means we have to add an electron. So we're going to get helium, and then 2s2 2p6 because I've added an electron. Okay, so cation is a positive charge, lose electrons. Anion, negative charge, gain electrons. Okay, and then my transition metals. Okay, let's look at chromium. Remember, we just learned that chromium has an unusual electron configuration. Okay, it's got argon 4s1 3d5. Okay, so let's say I have a chromium that's a +1. What I'm going to lose, okay, is that 4s1. So my chromium with a +1 charge is a 3d5. Okay, so I always lose my s electrons first. Now I can lose d electrons. Let's say I have a chromium, let's say it's a +3. Okay, it'll be argon. Okay, I'll lose that 1 4s electron and 2 d electrons. It'll be 3d3 because I've lost 3 total electrons. Now, what ends up happening is elements want to have an octet. So most things are going to ionize such that they will have an electron configuration identical to one of the noble gases. Okay, so if you notice, calcium again had the ion there, the +2, has the identical configuration as argon. Fluorine, when I make the fluoride ion, it has the identical electron configuration of neon. So what we call this is isoelectronic. So if I have the same electron configuration, I am isoelectronic to another species. Okay, so our atoms are going to tend to gain or lose those electrons to become isoelectronic with the noble gases. So this sodium and this fluoride ion both ionize to have the same configuration as neon. Okay, they're still sodium and they're still fluorine. Okay, they don't become neon because remember, it's the protons that set what an element is. This is just electrons moving around.